Alright, so I just wanted to go over a few homework problems. This year final homework assignment. Not completing it will, cause a slight drop in your grade. So please complete it. It's very easy. It's just doing these same problems, and these problems were actually on one of the final exams that I may have given your class. But these problems, you can solve them all actually using Excel equations instead of looking up values in the table and so forth. So I have an Excel equation sheet right there, which you can open up, and we're going to use that equation sheet to solve these problems. So, and I'm not going to solve all the problems in this YouTube video, but I'm going to solve at least 2 of them, perhaps 3. Anyways, so we have normal distribution. We're given the following information. What's the probability that x is between 20 and 25? Well, I say use the normal distribution formula. Let's look at our equation sheet. Here are our normal distribution formulas, and what scenario are we under? Well, in this case, we're trying to find the probability. We're just finding the probability that x is between 20 and 25, not x bar. So we're looking at the distribution of x right here, and here's the normal distribution probabilities that we have. Now, they're the same formula. It's a normal. You're going to type equals normal distribution just like that if you use either one of these. But this is the formula you would use, or you'd use these inputs if you're interested in finding the probability that z will be less than z. So if we wanted to, we could take our x value, our mu value, or r sigma, and convert it to a standard normal variable, and then use these inputs. Because what you do when you convert to a standard normal is you just you convert your normal distribution that has a mean of mu and a variance of sigma, and you transform it to a normal distribution that has a mean equal to 0 and a sigma equal, or a standard deviation equal to 1. And so for this normal distribution formula, the first argument in the formula is x. That would be like 20 in this case. The second argument is the expected value of the random variable in your formula. The third one is the standard deviation of the random value, or the random variable of the normal distribution. And the fourth one is either true or false. It's true if you're looking at cumulative distribution. So a cumulative distribution, I'll just open up to show you. So a cumulative distribution will give you, when you put in an x value into the equation, it'll give you the values, everything to the left. So the probabilities of your normal random variable being less than a certain value. And that's actually how I solve for the area to the left of z. Is it uses, even though it's built into the spreadsheet somewhere else, but it uses this z formula that you're looking at, this normal distribution formula that you're looking at right here. So let's go back to the problem. So what's the probability that x is between 20 and 25, and we want to use this problem right here, because we're looking at the distribution of x, and our normal distribution has a mean and standard deviation not equal to 0 and 1. So I will put that right there. Yep, that did not work. So in order to find this problem, the probability that x is between 20 and 25, we are going to find the probability that x is less than 25, and we're going to find the probability that x is less than 20, and then the probability that x will be in between 2 will just be the difference. So probability that x is less than 25, well, that's what this normal distribution, actually, yeah, norm distribution will do. So our x in this case is 25, our mean is 25, our standard deviation is 4, and always do cumulative 0.5. Now I can find the probability that x is less than 20, normal distribution, our x is 20 in this case, our mean is still 25, and our standard deviation is still 4, and we always want to do true for cumulative. And then our answer will just be the difference. There we go. And for demonstration purposes, normally the way we've been solving this so far is you'd find, the way that you find probability that x being less than 20 is you'd convert this to a standard normal random variable. So you would use this formula, z equals x minus mu over sigma. So, this is going to be equal to the probability that z is less than what? And we'll solve for this for demonstration purposes. 20 minus mu, which is 25. Put parentheses around that, and divide that by our sigma. And then you'd look up 1.25 in our table. Right here. And we'd find the probability of z being less than negative 1.25 or negative less than negative 1.25, as we looked up in the table, is 0.10565, which, if we just change the significant digits on this, here we go. It's the same probability, and the table uses the standard normal, so that's why we converted to the standard normal. But if it was already in terms of standard normal, we could have solved this probability by using this normal distribution. In this case, x would be negative 1.25. The mean for a standard normal is always 0. The standard deviation of a standard normal is always 1. and we still always want to use true for cumulative, and that gives us the probability as well. So function, you know, no matter what method we use, we get the same probability every time. It's a beautiful thing. Alright, so moving on. Real quick, number 2, you're going to use this formula, or function I should say, to find the probability of x bar being less than or less than equal to 26. And then you're going to do 1 minus that to get the greater than. Down here, you're going to use the normal distribution function to find the probability that p bar will be less than 0.8. Here, on this problem, you're going to use this confidence function to solve for e. X bar is given to you. And I will help you do this last one as an example. So we have a sample, we have a mean weight of 1.02. So x bar is 1.02. Construct a 95% confidence interval of the mean weight of all cereal boxes with the given information. Assume the population standard deviation is unknown. Since population standard deviation is known, we have the sample standard deviation we use instead. And thus, whenever that's the case, we use the t distribution instead of the z distribution. So let's open up these Excel notes. And I say, oh, I need to use a t distribution. I tell you when you use that t inverse formula. Where's my t? Oh, here's a t inverse formula. And nope, here's a formula for a confidence interval. That's what I'm trying to do. And remember, in a confidence interval, you have your point estimator, which is x bar. And then you plus or minus your margin of error. So your margin of error, E, is this entire term right here. And we're supposed to use this t inverse formula. The t inverse formula solves for the t of alpha over 2. So, to repeat, what's important about the t inverse formula is you put the total, your entire alpha into the formula, but it returns the t value as if you're doing a two-tailed test. Okay, so we know what x bar is. That's given to us in the problem. Now we just have to find what E is, and E, we have this equation right here, or it's just this part of the confidence interval equation. So there we have our E formula, and we know what S is, and we have square root of M. And now we just have to solve for T. Go back to our formula. This is what we want to use. And that kind of got blurry, didn't it? There we go. So T of alpha over 2 equals, and that's what we're looking for. It's a confidence interval. So T inverse, and then we have alpha, which 95% confidence interval, that means alpha is 0.05. And your degree, that's your probability, and then we have degrees of freedom, which is n minus 1. So there's our t. So now we can find our e term. It is t times our s divided by the square root of n. Let's put that in there. And let's check number 7. See if that's right. And it is. And also, all these answers, to these problems are in your prep final. So use these formulas, and if you're not sure whether you got it right or not, check the prep final to see if you're coming up with the same answer or the same answer slightly, very slightly rounded. Alright, thank you.